Maybe if we do a recap on what we did last week, we were dealing with string functions. And in these string functions, so I think I can introduce that. So last class we were dealing with string functions. And we said one of the functions that we have is a strcpy function. Then we have strcmp, that is compare. So we are comparing two strings. We have strlen, and then we have strcat as a function. So those are two main functions that we discussed. Those are the main functions that we discussed. And we said when you're using this str copy, we are copying one string to another. So if I have 1 and another string 2, so we are copying this, the value that is here to this. And then we had compare, we are comparing two strings, whether they are equal or maybe they are having the same presentations of characters. String length, we said we need to get the length of a certain number. String cut, that is concatenation, mostly when you want to combine two strings together. And that is why we said we can use string concatenation. So I think if you look at what we did, it's very clear. And I urge you to go back to your notes and try to read mostly on how we can be able to implement this. So today, I wanted us to start on another part of the lesson, which is still on a function. Remember, we are not through with the function. So we are still doing with the function or dealing with the functions. Remembering that in this function, we are supposed to look at inbuilt and user defined function. That is what you did. Then we said we can use what you call arrays, and I think you can remember what we said about passing by reference and passing by value. I think somebody saying that we have not covered that, and I repeated that at the end of that class. If you still have an issue, we can still repeat it after we are through with what we want to do today. And in this case, just a minute, I connect something here. So what we are saying is that we dealt with inbuilt functions, we dealt with arrays or functions in arrays or array functions. Then the next one that we discussed is about the string functions. The string functions. And then after that, now we are supposed to cover today. So I think on string function, we did it last week. So I think it is fresh in your mind on what we said. And I think I have explained that. But today, I wanted us to do what you call recursive function. Recursive functions. And then what you call Fibonacci. Fibonacci. And I want you to go to the question paper. If you look at the introduction of the big blue button, I have said we need to do some questions on past papers. So I am teaching this, then we go back to our question papers. And then after we go back to our question papers, we are supposed to maybe spot one or two questions that are using functions so that we can do it. And then we familiarize ourselves with those questions. So when you look at this, Fibonacci or recursive function. So we always do Fibonacci in recursive. Then when you do recursive, we are saying the values are repeating themselves. So you repeat the numbers. That is what you call, you have repetitions. Like now, if I give you 4, just a minute. If I give you 4, or I give you 6, if I give you 6, how many numbers repeat themselves to up to 0 or up to 1? So the first thing that we are supposed to understand within the recursive is that recursive should have a stopping point. Should have a stopping point. They should have a stopping point. And this stopping point that we are having is a 1. The stopping point should be a 1. That is automatically known on that. Then it must have a start point. And when you talk about a start point, for this case, because we are talking about number 6, our start point should be 6. How many numbers are there in between? Because now you have a repeating codation. So it must have what you call repeating codation. So in this repeating codation, we ask ourselves, how many numbers are from 1 or from 6, because that is the starting point, from 6 all the way to 1. So we come up with the first number, maybe which is 5, the next number, which is 4, the next number, which is 3, and the next number, which is supposed to be 2. So if we are doing recursively, or we are doing recursive numbers, we have to multiply and we get the recursive of 6. So we multiply these numbers so that we can get the recursive number of 6. So for you to get the recursive number of 6, you multiply 6 times 5, which is 30, times 4, that is 120, times 3, that is 360, times 2, that is 640, times 1, that is 640. So the recursive number, if I'm not wrong, the recursive number of 6 is 640. So that is the first thing that we are supposed to note in that case. But how will you be able to come up with this data? So in another case, there is what you call factorization. So you are doing what you call factorization of a certain number. So the factorization of 640 is 6, 5, 4, 3, 2, and 1. So we can say the factorization of 640 is 6, 5, 4, 3, 2, 1, which brings to a total of what you call the recursive of 640. So in this case, we can be able to understand that given as the presentation of this, we need now to see on how we can be able to calculate or maybe be able to come up with a function if we are given such or that. So maybe get the factorization. Get the factorization of 6. Get the factorization of 6 using C programming. Using C programming. So that is the first thing that we are supposed to note. We are getting the factorization given that now the factorization of that number is 6. So in this case, it's up to you to ask yourself, because a factorization is a subject of a function. Because it is a subject of a function, now we can be able to look at now how we can be able to call that. So automatically, you know this, hash include standard input.h. Then remember, because there is a function, maybe we can have a return type int fact. Maybe we can call it fact. That is the function name. And that number, we call it int n. We call it int n. And that is now what you call the function prototype. The function prototype. So in this case, we can now start our main, int main. And within our main, we need to look at the values that we have. So this is because it's a local variable, we can declare int, maybe k. And we can assign this k to 6 because that is the value that we have. So those are, we are starting from 6. So from this case, maybe we can return, we can get the output, and we say the factorization is the factorization is percentage D, or maybe you can say factorization of percentage D is equals to the percentage D. The factorization of that is this is equals to the percentage D. And then we quote that, we have that, and we are saying the factorization of K is equals to the value, which is the fact. Remember, we are now returning the function name, which is the fact of K, the fact of K. And then we can close that. Then from there, we have to return a 0. Then we can end that. So that is just a main program that we are supposed to have. So in this case, we need to have the main the function name, the function definition, fact int n. Then we can say if this number is 1, we're supposed to return 1. So we can say if n is less than or equal to 1, if I is less than or equal to 1, because we don't have the factorization of 0, we don't multiply it by 0, now we can say return 1, return 1, return 1, sorry, return 1, else return that number, which is 6. So return that number, which is 6, that is n, because n is the value that is now associated with the 6. Return n, which is 6. You multiply that by fact of n minus 1. Fact of n minus 1. So in this case, we are multiplying 6 multiplied by 5. And the chain continues. So in this case, we can say the function that we are having here, we can try to introduce the respective value that you are supposed to have within that. So I think we can code this. We see how it will work. Maybe we use, we can use maybe C compiler. Maybe we use this. So in this case, allow me to copy paste. Then I'll try to change whatever is supposed to be changed here. So like this one is supposed to be changed. This is supposed to be changed. This one is supposed to be changed. I don't know whether it is the right one. Yes. This one is supposed to be changed. So printf p is supposed to be changed. These quotes are supposed to be changed. These quotes. Return 0 is supposed to be changed. Int is supposed to be changed. Then if is supposed to be changed. Return is supposed to be changed. Else is supposed to be changed. Should be small letter. And this one is supposed to be changed. That. Let's try whether it will execute. So we have fact. So we have fact that, int that, k. So I think k is okay. K is in small letter. Return 0. Int fact, you open that. The return 1 is okay. And you multiply by fact. That is n minus 1. So what has it given me? The return is undeclared. So there is somewhere return. First use this function. Okay. We close that. So let's try to execute it. Expected semicolon. Why is it expected? So each undeclared is reported once only for each function. It appears. Allow me to use the one that we can see on the right side. Let's see whether this one can work. Let's use this, the one that we can see on the right side. So we have int function fact, return undeclared. Printf. And that. You see any error? Can't see any error, but it's not working. %d, %d. Okay, so there is an issue on this. So this is return 1. Let's see whether it will now execute. So you can see the factorization of 6 is 720. I don't know where we have gotten wrong when we were multiplying that. So remember we were supposed, maybe I can use paint. And if you look at this, we were looking at number 6 multiplied by 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1. So this is 30. This is 120. This is 360 times 2. That is 720. So in our calculation, the one that we did previously, it was wrong. It was wrong. But if you look at this one that we have already done here, is already okay. It's okay. So the factorization of 6 automatically becomes now 6 becomes 720. So that is according to the number that you have already been told. So when you're using this kind of function declaration or function interpretation, you can use it to present a very large number of program execution. Remember that even if you have maybe 5 million, you can still work with that 5 million. So we don't have any issue on the use of that. We can still use it. And for this case, maybe I want us, we try to modify this program. And I want us to modify without using the actual value that we have. And I hope you are listening. Are we together? Hope you are together. I'm not talking alone. Are we in the same page? Are we understanding what I'm talking about? Are we understanding? Yes? Okay. Maybe, okay, so if you are following, maybe we can proceed. And I want us to modify this program. So instead of initializing the value that you want to start with, maybe I want us to allow the user to enter. Maybe I don't want even to have I don't want even to have the printf function. I can start from scanf function where I say %d, then I have a dollar sign, an ampersand, sorry, then k, an ampersand k. So that is when we want to assure first, you enter the numbers that you want to work with. Maybe we try to execute this program, maybe we see whether it will work. So the factorization is 0. Don't know why. So maybe let's work with printf. Enter the value of k. Enter the value of k. The value of k. So it's not allowing us to enter. Don't know why. So when you're working, the moment you'll be working with the next one, maybe I can try to change this to the other one. We see whether it will still work. Let's see. That one, it was allowing us to enter values. This one, it was allowing us to enter values. So if I try to run this, still has an issue. I don't know the issue of this compiler. So k is equals to 6. Let's see. This one has executed on the other end. Let's see whether it will still execute on this end. So I think this one has an issue. That is what I can say, unless maybe hash include. Okay, that one is okay. I think now it is giving you the output. So let's see whether it will give the output when you are entering that. Remember, when you're using the offline, or maybe when you're using the other editors, it's very easy. So that one, maybe we can say 50. Or let's first of all work with 4. We see whether it will work. So that is 24. I think that is okay. If you try to run it or to execute it again, maybe if you want to have 900, and then you press enter, So automatically it's giving you the factorization of 900 is 0. Now that is a question that you're supposed to ask yourself. Why is it giving you a 0? Do you have any maximum number that you're supposed to have? Maybe let's see. 100. 0. When you want to work with maybe 10, those numbers start from, that is 10. So that is the value that we are having. Let's try to work with 11. 11 is that. So that is the question that you should ask yourself. Why, if you get the number that is more than 100, so you can restrict that still in programming. So why am I getting the issue here? So if it is 99, I'm getting an issue. If it is 50, what am I supposed to get? 0, 0. So if it is 30, you can get a number. So in this case, the data type that you have already declared here, remember we have said it is an integer. So if you have declared it as an integer, automatically we will have an issue because an integer does not allow more values. So if you look at these numbers, they exceed the 3 million, the 300,000 that we always have. So if you look at the presentation of an integer, it has a maximum number that we are supposed to have so that it can execute. So in this case, that's why if you multiply 100 with that, it will always get a 0 because it's above. It is above what an integer can hold at a given point. What an integer can hold. So that is why we need to understand that recursive function is a process of repeating itself in a self-similar way. In programming language, if a program allows you to call a function inside the same function, then it calls a recursive call of the function. And that is what you should be able to use as a declaration or how you are supposed to declare it the moment you are working with that. Function to call itself, so that is the first thing we should be able to understand within that. We can say that is the first thing that we need to have. Program need to careful to define the exit. So that is programmer need to define the exit of that program from the function. And these are the main conditions that you should be able to observe when you are using the recursive function. Because the moment you are using the recursive function, it should repeat itself. It should have an exit within that. And if you don't have an exit, it will always go to infinite loop. A repeat that will never end. It will keep on executing frequently, and will not end at a given point. So that is when you are working with what you call factorization. What about if you are working with Fibonacci series? And I think when you are in standard 4, mathematics standard 4, I think we are introduced on Fibonacci. And when you talk about Fibonacci is when you get the sum of the values. Like now, if I want to have 6 numbers, so if the first value is 6, so you are getting the first value. So the first number is 1. Then it is 1 plus 0, which is 1. Then 1 plus 1, which is 2. 2 plus 1 plus 2, which is 3. 2 plus 3, which is 5. Then 5 plus that becomes 8. Because 8 is not within the number 6, automatically it is not executed. So what we are saying, Fibonacci series is when you get the number, when you get the sum of the previous number, when you get the sum of the previous number. And when you get the sum of the previous number, now that one will always result to what you call the Fibonacci. So in this case, we are saying it will always result to a given value, and this is the program that I had already coded, where we are saying int Fibonacci, that is the function name, but we are declaring that function name with an I. So if I is equals to 0, just return 0. If I is equals to 1, return 1. So these are the first numbers that we are supposed to add. So that's why we are saying 0 plus 1 is 1. So you have 1. So you have 0, you have 1, and then 1. So 0, 1, 1. So because there is no need of giving 0. 0 is a null. That's why we start from 1, 1. Then return Fibonacci I. So we are saying we add the first one. If you add, then you minus the other value that we have. So I minus 1, which is 1 currently. Remember, it is now 1 plus 1 is 2. 2 minus 1 is 1. Plus I minus 2. Then you get the actual value that you are supposed to have on that. So I will copy this code the way it is, instead of writing from scratch, because I had already written that. And maybe we try to work that in an online. Maybe I can copy paste this. For now, I can copy paste that. Just a minute. So I copy this. So we copy paste that. So you can look at where we have an error. I assume that we don't have any error. So if you look at the first thing, giving us what? 0, 1. I want to call this program somewhere else. Maybe we use this so that we can see on the other end. If you execute this program, you'll be able to see the output where we have 0, 1, 1. So 0 plus 1 is 1. Remember, if you look at this program, we said 0. So first of all, note 0. The second one, note 0. So return 0, return 1. So 0 and 1, these are the first values that we have. So being the first values that we have, automatically we have to move to the next one. So it is 0 plus 1. So for this case, we are now adding 0 plus 1 is 1. Then from that point, we now get the next value. So it is 1, 1 plus 1, which is 2. Then 2 plus 1, which is 3. Then 3 plus that, 5. Then this plus this, which is 8. Then from 8 plus 3 plus 5, that is 8. 8, that is 13. 13 plus 8, that is 21. That is 34. So in this case, we must have 10 numbers. And these are the numbers that we have. We have said I is 0, I is less than 10. So we are looking at a 9 number. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Because we are starting from 0. That's why we need to have 10 values. But if you had already said less than or equal to, so and we execute this program, it's supposed to add another value. If, okay, just a minute. Function, expected expression before token. Just a minute. So that one is executing less than or equal to. So it has added now that the 55. So that is 21 plus 34, that is 55. So that is what we call the Fibonacci series. That is what we call the Fibonacci series. And maybe if there is a question on that, maybe you can ask before we proceed. So is there any question up to that point? So you can ask questions. So I'm waiting for your questions. So I'm waiting for your questions. Okay, there is no question. So is there anybody else with a question? Okay, so that is what we are supposed to look at in functions. And remember, if we can go back maybe to what we have already covered, maybe allow me to go back to what we have already covered from the introduction part. We have covered introduction, and this is definition of term. We have looked at the control structures. Then from introduction, control structures, then we have looked at operators. Then from the operators, the other things that we have already looked at, we have looked at arrays. Then we have looked at pointers. If I'm writing something that we have not covered, can you tell me? Then we have looked at what you call functions. So we have looked at introduction part. I don't want to elaborate further on what we have within the introduction part. We have control structures, we have operators, we have arrays, we have pointers, and then we have functions. We have functions. Is there anything that we have covered, or is there anything that I have written here we have not covered? Is there anything I have written here we have not covered? So maybe we can answer that. So is there anything that I have written here? Is there anything that I have written here that we have not covered? Anything? Okay, so got an answer from Onyango. What about others? Felix, Isa, Rachel? Anything that I have written there we have not covered? What about Aisa Onyango? So, okay. So I think we have covered everything up to that point. And I want us, maybe we write what we are supposed to cover, because that is part of what we needed to cover before time, or we needed to cover before today, that is before July. And for this case, there are other things that we need to cover here. One, we need to cover what you call queues and stacks. Then we need to cover what you call sorting and searching. Sorting and searching. We need to cover risks. And the last one that we need to cover is on files. So all these are data structures. So data structures. And these are data structures that we call non-linear data structures. And linear data structures. And then the last one that we need to cover here is pseudocobine and binary trees. And binary trees. So those are the remaining subtopics, not subtopic, topics that we are supposed to cover, and we complete with our classes, or we complete with our classes, then we start our revision. So in this case, I want you to go to your question paper, because I know you have those past papers right now. And I want you to maybe look at the question paper that we have. If you have a hard copy, I urge you, maybe you use your mic, then maybe you read to others, or maybe you can write it somewhere on the message box. Maybe you write it on your message box. Then after that, we answer that question. So let me give you 5 minutes so that now you can respond to the question. So look for a question on our functions. Then we do that function together. Is that okay? So can we use the forum? Can we use forum, or we use the big blue button? Can we switch the big blue button, we go to the forum, or can we use the same big blue button maybe to answer the questions? So I'm waiting for your response. We use the forum, or can we use the big blue button? Remember, each and everyone has to look for a question, and then maybe you give us that question so that we can answer. Okay, so we can use the big blue button. Onyango, I think you can look for a question. Perex, maybe you have your own question. Aisa, you have your own question. Rachel, you can look for a question. Then after you see that question, maybe you can use your mic to read that question, or you can write that question on the canvas. Those are two methods that you'll be using, because still you can present it, but if it is a hard copy, it will be a challenge. It will be a challenge because you must use your webcam. of which cannot be a challenge to. And when you're using your webcam, you can, maybe you screenshot. You can screenshot. And when you screenshot, you can send to this platform. So 5 minutes. So have you seen any question? Have you seen any question? Unless, if you don't have past papers, it's very hard for you to see the question that I'm talking about. So I know everyone has a question paper. Everyone has a question paper because I gave one of you, and maybe you photocopied them. A bunch of past papers. Felix, do you have any question papers? Okay, have you found any question? Have you seen any question? Isa? Isa, do you have any question? Onyango? Siaba? And I can see we have new students here. So what we'll do, just look for those questions, then you post on WhatsApp. So you screenshot them, you post them on WhatsApp. Because we have a group for WhatsApp, then after that, we'll be able to proceed next time. So I don't want to start on this topic because I want us to start on sorting. I'll give you this one. I always give an assignment. So can you go and look at what is a queue or a stack? I'll write this assignment that you're supposed to do on your portal so that you can send to me. So this is an assignment that I will give you. So please check on the portal after 5 minutes or 10 minutes after we end the class. Then I'll directly start from the sorting. And then we go to searching techniques. Then from there, maybe we can go to lists, then files, and we proceed up to the last topic that we are supposed to cover. So at this time, maybe we can end at that point, but let us proceed from next week. My friend Siamba, you are very late. That's why I have already posted the question here. Okay, Anthony. Okay, I'm talking to these topics that we have here. The ones that have been highlighted with a red. These ones. These are the topics that I'm saying we need to cover. Oh, sorry. Let me see. Oh, sorry. But I had shared before. Okay. Okay. Can you see now? So I think you can see now. Okay, these are the topics that I'm saying we need to cover them. And before we cover these topics, we must answer some questions from those past papers that we have. So we cannot proceed before we answer some questions from the past papers that we have. So that's why I'm saying, just look for those questions. Then after looking for those questions, you screenshot them or you take a photo. Then you post on WhatsApp, because we have a WhatsApp group, which is structured programming. Then when you post there, I will be able to relay them from there. So I will relay those questions from there. Then after that, we will be able now to proceed to the next topic. And that's why I'm saying I will give you an assignment on queues and stacks. On queues and stacks. And okay, you can still be added to that group. Talk to Anthony Onyango. Please, Onyango Joseph. Onyango Joseph, please, can you add Anthony Siaba? Is that okay? Umepata moja. So, but now I want you still to add Siamba Anthony. I hope you are the admin, if I'm not wrong. Are you the admin? Who is the admin of your group? Who is the admin? Peter. So can you talk with Peter? Please, can you talk with Peter to add you, Anthony, so that we can be communicating on that platform? And I want to send a WhatsApp message. Not a WhatsApp, sorry. I want to send an assignment that you need to do on queues and stack. And the deadline is on Wednesday, sorry. Then from there, we will do some other questions after we do the question that Onyango has. Then after that, we start from sorting and searching. So when you start from there now, we can be able to move ahead. So we are almost ending with our syllabus. So I'm expecting maybe before August, we'll have ended. And before August 15th, we will have ended or completed our syllabus so that we can start our revision on that. So please, Onyango, you can maybe give us a question. Is it possible to use your mic? Maybe you write it somewhere, or what can we do? You screenshot maybe. Can we do it next week? Is it possible we do it today? If it is possible, maybe you can give us a question. If it is not possible for now, you can maybe use your WhatsApp maybe to post that question so that everybody can see. Because I know there are those people without question papers. So Grace, do you have a question? Grace, and Faith. Those are red commas. Okay, so if you are posting on WhatsApp, everybody can see that. So Grace and Faith, red commas. Why were you red? So have you posted? Can't see it. Or we are posting on another page. So post it so that I can display the page. Okay, I have seen it. So let me display that page. So there is an issue on. There is an issue on. So I hope you can see that question. Can you see the question? Can you see the question? Okay, so I think you can see that question that I have already posted. This is the question, and it is not clear. I don't know whether it is a function. So write a Pascal. So I want you to do away with the Pascal. A Pascal is another programming language. So maybe write a C program that accepts an integer less than 10. The program should then factorial of an integer through a procedure. So in C programming, we don't have a procedure. You don't have a procedure. But when you talk about in C programming, we have what you call a function. So in this case, we are looking at the integer values that are less than 10. So they are less than 10. And now we want to compute the output, the factorial of an integer through a function. So this is the same program that we had already written. Unfortunately, I have done away with that program. I don't know whether I can still trace it somewhere. Let's see. C compiler. So we are looking at this. So this is the program that we are looking at, not this program, sorry. So we declare, let's write that program from scratch. So we are supposed to have a factorial. So we can say int fact. Let me call it fact. And that number is b. So there is a function prototype. Then from there, we have main. We have main. We have main. Then from main, this is where now we need to write a program that accepts those 10 values that we have. So in this case, we can say we have int k. Int k. Then we say for k is equals to 1, k is less than or equal to 10, k plus plus, k plus plus. Then within here, we can now get print f we have percentage e, and this one we can call it fact of k. Fact of k. So when you come to this, Now we will have int. Remember, now we are working with the function now. So you will have int fact, where we have int b. Then if b is less than or equal to 1, less than or equal to 1, then what are we supposed to do? So return 1. Return 1, else return b. Because it is factorial, you multiply that by fact over b minus 1 over b minus 1. So in this case, we can end that with a semicolon or there. So let's try to see the output that you are supposed to get. So 1, 2, 6. So when you multiply this, we need to give you the values that we have already gotten here. So just try to do that question. Maybe you multiply 1, multiply by 2, multiply by 3, multiply by 4 up to 10, which is not supposed to give you that answer. So just look at that. That is how it's supposed to be used together. So we can present this in this way. And the numbers that you require are 10. So you need to get the factorial of these 10. So that's why we have already used that execution. So just look at those questions that we have. Maybe we can proceed next time. We proceed next time. So I think I have slightly answered that question. Now you are okay now to go to the next question. So Onyanko, can you take that number? Maybe you and Anthony. I have seen that. So let's end at that point. Maybe we proceed next time. Is that okay? So I want you to look for other questions you post, and maybe when you are posting, they should be clear. So let's meet next week, and please, next time, come early. There are those people who are not coming early in class. And remember, I said even if it is one student, I will still be teaching that one student. So I have seen most of the students here who are not coming to my class. If you are not coming in my class, can you make sure that you go through the notes that I will still post others on your portal as I post that assignment that it's due on Wednesday next week. So please, can you do that? Can you do that? Then we meet next week.